In this video, we are going to discuss about neighboring group participation. The short form, it is NGP. It is also known as anchimeric assistance. What is this? Consider aliphatic nucleophilic substitution. Take this compound. There is leaving group. It may be say tosylate. If I add acetic acid, what I get is OAC. Since it is primary alkyl bromide, it prefers to undergo SN2 mechanism. That means the nucleophile has to attack backside and it has to go like this. Since it is primary, I didn't mention here. If it is tertiary, then the OAC should be the other side. So basically it is backside attack. Generally for SN2, this acetic acid is not a good nucleophile. For SN2, we need a strong nucleophile. Say this substrate undergoes solvolysis at certain rate, say K1. I go for one more substrate with same leaving group. Here I have same hydrogen atom, but here it is phenyl now. The same condition, I have taken acetic acid. I get the product. Say the rate it is K2. It was observed that K2 is several times greater than K1. What is the reason? I also go for one more substrate, that is this compound. I have introduced the pH 2 carbon away from this leaving group. Here it was on the next carbon, but here it is 2 carbon away. The same condition, say acetic acid, say it is K3. We get a product similar to this. We get like this. But if you compare K1 and K3, it is almost same. I use this. It is almost same. Then why only in the second case it is very high? That means there should be some effect of this phenyl group when it is next to the leaving group. So that is why it is called neighboring group. It should be on the next carbon. It should not be far away. It should be on the next carbon, and that group involves in the nucleophilic substitution reaction. So that is called participation. So neighboring group participation. Generally, when the solvent acts as nucleophile, we call this as solvolysis. Like hydrolysis, basically hydrolysis is a solvolysis reaction. When you use water as solvent, it involves in the reaction. So that is called solvolysis. So whatever solvent you use, that acts as nucleophile and it displaces the leaving group. So such reactions are called solvolysis. There are several types in that: hydrolysis, acetolysis, methanolysis, goes like that. What are the groups that can involve in such neighboring group participation? Simply, I can say there should be a leaving group. After that, the neighboring group should be electron rich. If there is electron, it may be lone pair of electron, or it may be alkene, or it may be aromatic ring. If the electron density is more, that may involve in neighboring group participation. So under that I can categorize the neighboring group with lone pair of electron. For example, I go for oxygen and nitrogen. So we have lone pair on this. Generally halogen, since it acts as leaving group, we don't consider that. If there is oxygen here on this carbon, oxygen or nitrogen is attached, then there is possibility for anchimeric assistance. The second one, it may be double bond or triple bond. Generally we go for double bond. If there is any double bond, it can promote. Triple bond, it is somewhat less, so generally we omit that. Third one, it may be even aromatic ring. So that is the example whatever I have given. So this is the first category. Generally these categories in aliphatic chain. In the case of bicyclic compound, so there is no double bond, there is no oxygen with lone pair of electron, or there is no aromatic ring, but still the solvolysis will be faster. This leaving group and the alkyl group, they should be trans to each other. The dihedral angle should be 180. In such case, this alkyl group itself can involve in neighboring group participation. So this is only in the case of bicyclic system. The reason is the strain, ring strain makes this to undergo the reaction. The third one, it is acetate. Acetate, it can come under this, but this is basically acetate or benzoate. There is oxygen atom with lone pair. This may involve in anchimeric assistance. But not only this, even this oxygen can involve in anchimeric assistance. So this already we have seen in Provost-Woodward reaction. Refer this, in that this lone pair of electron will involve in neighboring group participation. Because of that we get cis and trans diol. Very often one question is asked from this. If we go through some problem, then you can understand this better.